to look at exponential functions. And exponential functions are those in which the exponent has the variable. So previously, we were looking at where the base was the variable. And we could look at things like this. But now what we're going to do is we're going to change this up a little bit. And now the exponent is going to have the variable. And so it can look like y is equal to 2 raised to the power, or maybe y is equal to 3 raised to the x minus 1, things like that. And in these cases, this is our base, both of these, and it's going to be important to know what is our base. And of course, these are our exponents. And in this case, this entire thing is our exponent. A couple of things about our base and our exponent. Main thing is that the base has to be greater than 0, so it has to be positive. Where I'm talking about the base, it's the item that is actually raised to the exponent. Also, the base cannot equal 1. The reason it can't equal 1 is because you have to think about, what is 1 raised to any power? Well, 1 raised to the third power is 1. 1 raised to the negative third power is still 1. So if we raise 1 to a power, it doesn't change us any. But when we look at bases and we think about them having to be positive, what I'm saying is this is still okay because my base here is just the 3. The 3 is the only thing raised to that x power. Whereas here, I would be looking at the entire negative 3 raised to a power. And I can't have this for multiple reasons because I could end up with multiple numbers and everything. We're talking about functions. They have to be a one-to-one function. And in this case, we may not have a one-to-one function. So this is not possible. This is. When we look at these exponential functions, we are still going to use those transformation rules. And so let's review our transformations and then we'll get into actually looking at the graph of our exponential functions. So whenever we look at, and I'm just going to use 3 raised to the x power, if I have something that is added or subtracted up here in the exponent, this right here is going to move me horizontally. So this is our horizontal shift. It is just like anything that was inside the parentheses, underneath the radical, inside the absolute value signs before. So a positive will move us left, and a negative will move us right. Now, if I have something added or subtracted out here, in other words, not in the exponent, but out here, that is going to be our vertical shift. It is away from the x, so it is going to move us vertically. A positive will move us up, a negative will move us down. If I have a negative sign sitting here, this is going to mean that I have a vertical reflection. Meaning I flip down. Okay? Remember, anything sitting out here is that vertical, meaning up and down. Anything that is up in the exponent is going to be that horizontal. So this will be a horizontal reflection. And so what this will do is this will flip left and right. So it's the exact same type of transformations that we discussed before. And these transformations are going to be important whenever we're talking about like a horizontal asymptote and everything. So let's think about the function f of x is equal to 3 raised to the x power. If I want to graph this, and let me just come over here, I'm looking at f of x is equal to 3 raised to the x power. So I can plug in some numbers. I can look at a -3, a -2, -1, 0, 1, 2, and 3. So if I plug in a -3, that means I'm doing f of -3 is equal to 3 raised to the -3. Well, I know what 3 raised to the 3rd power is. That's 27. The -3. So whenever I have a negative in the exponent, what that's going to tell me to do is that's going to tell me to make it a fraction or to flip my fraction. So that's going to become 1 over 3 to the 3rd power. A negative in the exponent tells me to put my base in the opposite position. So here it's in the numerator basically, because remember 3, a whole number, is always written over 1. So now I put it in the denominator. If I were to have something that looked like this, what this is telling me to do is it's telling me to flip this fraction, which would just become 3. And when I flip it, I get rid of the sign. And so that would just become 3 squared. And so a negative in the exponent is telling me to flip things. And so here I would have 1 over 3 to the 3rd, which is 1 over 27. So this would be 1/27. When I plug in a -2, I'm going to do the exact same thing. I would have 3, not a 2, I would have 3 raised to the -2. So that would be 1 over 3 squared, which is 1/9. F of -1 would be 3 to the -1. So that would be 1 over 3 to the 1st, which is just 1 over 3. Any number raised to the 0 power is going to be 1. And then 3 to the 1st is 3. 3 squared is 9. And 3 to the 3rd is 27. And we can graph this. Now it's a little bit difficult. We've counted by 3's on this graph so that we can do 0, 1, 1, 3, 2, 9, 3, 27, so that we could get the 27 in there. And what's happening is we're going to come and y'all know I can't draw a straight line. It'll look something like this. Okay? Now you'll notice that it's not going to come below here. Any exponential function is going to have a horizontal asymptote. we start with those horizontal asymptotes being at y is equal to 0. Because we can't go negative. Okay? Now if I have a negative sign in there, that's going to change us. But we start with that horizontal asymptote. You can also look at this and you will notice that my domain of this will be from negative infinity to positive infinity. And my range, not my rame, my range will be from 0 to positive infinity. Now this is just as a basic exponential function.